Assalamualaikum warahmatullahi wabarakatuh and hi, we are from Sameena, Group 8. Our project is known as Lupus Teduh. Here are the group members of Sameena who contributed in the project. Lupus Teduh is a project to find a device that could reduce the risk of unexpected rash occurrence on lupus patients. Research has shown that photosensitivity differs between patients, making it difficult for them to be aware of symptoms in their daily life. The target user is lupus patients with rashes triggered by the photosensitivity. These are the 4 devices we made as our benchmark. Sunsprite, L'Oreal wearable UV sensor, and Netatmo UV bracelet have the same reasonings. Meanwhile, Sunframe is lack of monitoring software compared to the others. Thus, Lupus Teduh will complement the other 4 devices by providing automated daily UV collection. The design specification is to create a wearable device that can detect UV light exposure and record the exposure daily. An app was created to help patients to monitor the exposure and notify them before they reach their limit. All records will be stored in the Lupus Teduh app. These are the items that we purchased and custom built in pursuing this project. We spent RM112.70 merely for the materials. Despite some features, we believe it worth the money spent on this project.
This is the mockup for Lupus Teduh device. It has 10 essential components to be built inside the device. This is the circuit diagram for the Lupus Teduh device. It has LCD module, Arduino Nano, UV sensor, ML8511, RTC module, Bluetooth module HC06 to connect the device to the apps, slide switch to on and off, push button to when the rashes triggers, and also the battery.
This is the block diagram for our device that shows the data line and 9-volt line. We are using Bluetooth module HC06 for a two-way communication where it can be receiver and transmitter. Next, the slide switch is used to power on and power off the device. Moving on to the flow chart, when the slide switch is high, the device will be powered on or else the device will be turned off. Next, the LCD will display our product name, which is Lupus Teduh, and short user guidelines. The device will be connected to the phone Bluetooth and the value of UV intensity max reading is initialized to 1.0 mW per cm2 as it is the potentially harmful UV intensity for non-lupus patient in 10 minutes of exposure. Then, the LCD will display real time and the UV sensor start to monitor the UV intensity for every seconds. There are 3 conditions, which is the first one is when there's rash occurring on the patient, they will push the button on the device and max reading value will be updated with the current UV intensity value as it is to record the maximum intensity that the patient can be exposed to. The device next will continue monitoring the UV intensity. The second condition is when the sensor detects UV intensity approaching 90% of the new max reading for 5 minutes, the LCD will flicker the warning and sealer Teduh sign along with the pop-up notification on the app until the user turn off the warning through the app. The last condition is if the time shows 12 am, the device will be set the max reading to 1.0 again since the patient UV intensity differs every day.
The project design is a wearable device that should be suitable for the user to wear by considering the size and weight of the device. The UV intensity recorded daily will be collected automatically. This data will be used as historical data for medical record purposes. A software notification is used to alert users of their maximum UV exposure. The alarm is triggered when it detects the light with 90% of the user's maximum UV intensity, and the recorded UV light intensity is in the range of 280 to 350 nanometer. Thus, the UV light intensity unit displayed on the device is milliwatt per centimeter squared.
Moving on to our Lupus Teduh application. So we start the app development with homepage screen. On the background, you can see the block coding for our application. We are using the MIT Inventor. So the user firstly need to prompt their username and password to sign up for our application. Then just use the same username and password to log into the application. Then you will prompt to the next page or the next screen, which is the application. The application page consists of 4 different features and a lockout button. So the first thing we will go through the guidelines. So when the user click the guidelines button, they will prompt to the other screen which consists of our guideline. Next, we will try the button about us. When the user click about us, they will be prompt to the website that will show the background information and the progress of our project. So back to application page. Now we see the history page. The history page consists of the data recording of our UV value. So we already display the date and time. So the user just need to put the month that they want the recorded data. Just click the data and the data will display on the blank space below. Next, if the UV value is reaching the maximum, so there will be a pop-up notification that give warning to user to alert of their surrounding UV condition. We move to the last feature, which is the tracker page. On the tracker page, we will connect the Bluetooth using HC06, which is the Bluetooth module for our project. So after we connect, the display will display connected in green, and it will display the value of the current UV. And lastly, on the application page, there is a logout button. When the user press the logout button, they will be directed to the home page.
We will now proceed to the design validation of the device. Firstly, switch is turned on to turn on the device. On our device, it will display Lupus Teduh, which is our logo, and then we will give reminder to the user to press the red button if they feel any rash occurs on their skin. After that, the device will display time just like a normal watch. Next, we proceed to the Bluetooth module, which is the HZ06. We can see it is blinking, which indicates that it is waiting to be connected. Once it's connected, the Bluetooth module will stop blinking. We move on to the data recording. If the user feels any rash occurs on their skin, they will record the data by pressing the button, and the LCD will display the light intensity at instance. If the sensor detects potentially harmful lights for the user, it will display warning sila berteduh and also pop-up notification on the device. The user have to press OK on the apps to stop the warning.
The value proposition for our project is as follows. Lupus Teduh, your skin guardian. We help lupus patients to be safe in the presence of light environmentally by personally measure their UV sensitivity and self-data recording. By having the device together with the application on their smartphone, it helps them to understand better on the UV sensor and how we kept the data for the future reference for the patient and also for the medical purposes.